Now I've just got one more thing to do to finish this off. Actually, R is going to be building a string, so although that is correct, it's not going to be correct in my next item, the full adder. So we're going to have to be careful, because I'm going to have to build the string as I'm going. This is the first item, so whatever that is, it's just going to put one item in there. I don't really need to build on this string. It probably would be advisable just to add the string at the end, so I could just put plus R, and that would really take care of, oops, in the wrong place, plus R, that would really take care of the building of the string, because I'm adding it onto what was there previously. But as this is the first time, it's not really necessary. So let's just keep it out and see what happens. So I'm going to take off the print statement as well. I don't need that anymore. Now, so if it isn't the first bit that we're dealing with, if we're moving along the bit pattern in columns, then I'm going to need an else. We're going to be doing it 7 times now. So that's the first time for 8 bits, and now I've got 7 more calls to the full adder. I'm going to do exactly the same thing. I'm going to do result equals full adder, and I'm going to call or pass in the parameters. It needs, as we've done here, it needs whatever that, so I'm just copying, it's going to need the a value as a string. Now by the time it gets to here, index is going to be 1, and the string index is going to be sort of 6, so we're going to be looking at this value here. And I'm going to need to do exactly the same as I did previously by taking that. So that should work quite nicely. But in the full adder, I've got 3 things. I've got A, I've got B, and I've got the C. Now, I haven't set C to begin with. In fact, I could probably just get rid of that, but it might not be advisable to do that. But I haven't set a value for C, but I do know the first time through the loop, C is set there. So I have got a value for C, and all I need to do is send that carry in as well. So I've got the first bit, the second bit, and the carry. That will work it out, and that will give me a result. We can see that. So if I just do print result and run that, we can see what's going on. I do expect an error at this point. There we go. Because we are trying to run along the string and we are not doing anything with that value. So we're running off the edge here, and there's nothing to add to it. Oh, actually, I'm telling Porkies I've got one too few in there. Int B, that's it. Let's try that one. I am still expecting errors to occur because I'm not running along the full string. There we go. So that's what I get when I run through. I've got my value, my sum, and I've got my carry there. So let's get rid of that print result. We're going to do exactly the same thing that we did here. We're going to build our string. Is the string of the result in position 0. But this time I must add on what I did before. Otherwise I would just keep getting 1s and 0s, not a full binary number. And my carry is going to be exactly the same as this, so let's just copy that. And there we go. So that is the full adder. Do the half adder first on bit 0, and then do a full adder for the rest of them. When it's all done, return R back to the calling program. So I'm going to now uncomment that result. So result should be the combination of these two, the addition of these two, and it should be 0 0 0 0 1 1 1 1. So let's try that out. And there we go. We've added two binary numbers just using logic. Now, the only thing we're going to need to be careful of is if we get an overflow. So if I put a definite overflow in by adding these two together, so when it comes to this end, it's going to add these two together. It's going to write down 0 and 1 in the overflow. We're not really taking that into consideration. So let's take a look at that. So there's my result. Notice it's given me 15, but we've got no idea about the overflow whatsoever. And it really should error and not give me 15. It's certainly not 15. If it was 15 before I put the ones on the end, but it's certainly not 15 now. So I need to take that into consideration. So before I return my value, I really need to check if C is equal to 1. In other words, if we've got an overflow, then we need to print out overflow error. So that should be the end. In fact, I don't need to print overflow error. I can just set R, because R is a string, R equal to overflow error, and it's going to print out overflow error. So let's try that one. There we go. We've got an overflow error. If I take that 1 out of there on B, put a 0 back in, that is not going to overflow. It's going to be the value 1 0 0 0, so 1 with 3 zeros and then 4 ones. Let's try that. There we go, 1 3 zeros 4 ones. So it's adding up nicely. So we've got something that adds up to binary numbers just using logic, because we set the logic up here. And this first piece here only deals with the half adder on 1 bit, and then for the next 7 bits it deals with the full adder. That's okay, it's not brilliant. There are still lots of problems with the program, and we will put that right in the next video.